Right. So the next part that I am going to discuss is concatenation. Concatenation means we are going to combine multiple matrices together. So if I relate to data analytics, so the same technique can be used to combine multiple data sets together. Right? Although they are matrices, here we will learn how to concatenate matrices. The same technique can be used to combine multiple data sets together. So the next part, what I'm going to do is, I'm going to talk about concatenation. So the first one is row-wise concatenation. So for example, if I take like this, np.concatenate, and if you put a comma b, remember there are two brackets here. So this will be concatenate row wise, and then the output will be like this, row wise. So the first one is A, then you have B. So the row wise concatenation, you will get A and B like this, in this fashion. So you have same number of columns. Let's say you have two data sets. You want to combine into one. We can use this command, which will combine two matrices together. When you put A comma B, you have to put as a tuple, right? So you will have, see, within this, you will have A comma B. Right, got it? Okay. These are just simple commands that we are trying to understand. There's another similar command. Same thing can be done using np.vstack A comma B. Same output. VStack means vertical stack. We stack the matrices vertically, so we are getting this output. Then when you combine column wise, what will happen? When you have column wise, now this is 6 by 3 matrix, isn't it? 6 rows, 3 columns. Column wise will concatenate like this, which means you will get 3 by 6 matrix. Okay? So let's look at how we combine column wise. If you look at help, np.concatenate will give you more information about this method, and it basically concatenating matrices, and you have couple of things. First of all, you can see here we use A comma B, we concatenate only 2, but you can have many. And there's something called axis here. This is what defines a row or column. Axis 0 means row or column, right? So for example, in my case, I put the default value 0, that is row wise. If you want to make it column wise, you have to make it to 1. So therefore, the first command is, if you want to do this column wise, I will update slightly different way. So I will say the axis should be 1. So by doing so, what we say, this should be column wise. So the brackets are the issue. Bracket should come here. You see, we'll get 3 by 6. The same thing can be done, make a note of this, horizontal stack. So the other command is np.hstack a comma b. Okay, now that you know all the methods, can you combine all these 4 to a 1 like this? Can you combine everything like this? A, B, C, D. It should be 6 by 6, right? Can you combine all the 4 to make a 6 by 6 matrix which you have A, B, C, D? Finished. Were you able to combine 4 together? Yes. What is the code you have used? Strategy? 2 edge stacks and then? You have V stack. So you can have a V stack, within that you can have 2 edge stacks. Or you can have edge stack and then you can have 2 V stacks, right? Okay, good. We came to the last part of this. Let me discuss some elementary functions. So let's say we have 2 matrices like this. Let's say A equals np dot array 1 2 3 4. Let's say we have another B. Seven and 8. So there are methods if you want to add content in A and B. Remember, these are called elementary because these are element wise functions. For example, here when you say add A comma B, all the elements in A and B are added together, and this is what you will be getting. So we have 1, 2, 3, 4 in matrix A, 5, 6, 7, 8 in matrix B. When you say add, what will happen? 1 is added to 5, that is 6. 2 is added to 6, it's 8. 3 is added to 7, it's 10. 4 is added to 8, it's 12, right? So similarly, if you use np dot subtract A comma B, yes, you will get minus 4. So basically 1 minus 5 is minus 4, 2 minus 6 is minus 4. All the differences are minus 4. So similar to that, try multiply and then divide. So similar way, try multiply and divide and observe the outcome. So what happens here when you have 1, 2, 3, 4 plus we have 5, 6, 7, 8. It's element wise. 1 plus 5 is 6, 2 plus 6 is 8, 3 plus 7 10, 4 plus 8 12. Yes, element wise. So when you multiply, what you get? So 1 into 5 is 5, 2 into 6 is 12, 3 into 7 21, 4 into 8 32, right? element wise. Right, done. Okay. Next. Okay, so what do you think about this answer? Yes, we have matrix 3 by 3 matrix. We have 1, 2, 3, 4 minus 5, 6, 5 minus 6, 7. Yeah, mean value means you added everything. So that means this is 6, 12, 12 minus 5, 7, 4, 11, 18, minus 6, 12, 5, 17. 17 divided by 9, right? So it goes on like this. So that's what we got it. Yes. But that is mean value of all the values. But we can get row wise and column wise. Row wise and column wise. So if you need to get mean value row wise, here is how we go to np.mean. A will say axis is 0, which indicates row value. So row value, when you add it up, what will happen? 5, 4, 9, 10, 10 divided by 3, 3.33. Then this one, minus 11, minus 9, divided by 3, minus 3. Then this is 13, 16, divided by 3, 5.33. So this is row wise. Yes. Similarly, you can have column wise as well. So column wise, it's a column wise, sorry, row wise, right? No? what I meant earlier is in this way. Is it row wise or column wise? It's column wise. So make a change accordingly. So the column wise is this. Then we'll take row wise. So make a change accordingly. Then row wise we will get 2, 1.6 and then 2 again. So 3 plus 2, 6, 3 plus 2, 5, plus 1, 6 divided by 3, that is 2, right? Then we have 5 divided by 3. Then again 6 divided by 3. Similar to this, you can use summation. This is mean. The other functions you can use is sum function, and to get product, you can get product function. So we can have sum, product. So instead of mean, if you put sum, it just sum up all the numbers together. Right. Are you comfortable with matrix manipulations? Yes. Vectors and matrices. That was the session that we discussed. So we use a module called NumPy to do that. We discuss how to represent vectors and matrices and various ways to create and manipulate. Right. So this knowledge will be useful for the next part because they are connected. So shall we move to the next one then? Too much? Enough? Need a break? The next one is graphics. Maybe you can have a little bit of fun there. Yeah. Actually, you know, I mean, like, so when I actually do teach in university and other places, so once you actually master up to this point, that means we can easily switch to gaming. You know, there are game libraries where you can work, and the game, for example, if you take like you know, board games, that's simply representation of matrices. I don't know whether you have realized that. Or card game, which is a game basically representation of matrices. Right. Since we are going to for data analytics, the next topic or the next library that I want to discuss is visualization. There are many visualization libraries are available. So the visualization libraries, there are many, but this is usually the basis which we call Matplotlib. Actually, this particular library actually built for MATLAB. Have you heard MATLAB? Like in AutoCAD, you know. This is actually called MATLAB is actually matrix manipulation we use in scientific experimenting, and also like for example electrical and electronic engineering, we have a lot of libraries developed. So the Matplotlib is actually visualization actually developed for MATLAB programming language. But later, once for the Python, they also ported to this. So now this is one of the commonly used library. There are many libraries. Out of that, Matplotlib is another visualization library. So what kind of a graphs you can actually create? You can go to examples. It's a matter of now going through the codes. Now, for example, we are going to looking at how to create bar charts, right? Something like this, and hopefully the codes, the representation should be a little bit familiar to you. For example, here you will see there are a couple of lists we have defined. Yes, the data structures that we have discussed. So things like this, once you are master, it will be very familiar to you. And then, these are some of the other libraries which you can actually define. So I guess you have already used some other tools which you get the visualization like this, but you don't know how they have built. Sometimes you don't have a control over the colors, the themes. You have some, but when you learn programming, you can do wonders because you know everything, right? So exactly that's what I want you to do. So let's look at how we can create simple ones, and also like the basic scatter plots which we will use to visualization. So I'm going to give you like some basic visualization. More complex one you can revisit here. Yes, just copy paste the code, you can update. Only thing is you need to understand what is going on. Right. So let's start our session on plotting. So I'm going to have, so which task is this? Task number 4 or 3? Okay, we have task 4. Hopefully this is the last task for today. Right, so we are going to discuss about the data visualization. The first thing is we need to understand which library we are going to use. The library is called matplotlib.pyplot. Let's rename as PLT. I will explain what this means. We also need NumPy, so we'll say import NumPy as NP because these are the libraries that we have used. So any plotting we need to have at least 2 sets of values for x and y. Let's say we'll define our x's as np.array. Let's have some values. Let's have values for y as well. That's all. Okay, we get simple plotting. So we define x and y with these values. So manually we put some values. Actually, instead of just typing the numbers, you could have used a range. Yes, for this one, I hope you know how to do that. And the graphics will be a very simple one. It's scaled the values in x and y and represent like a blue line graph like this. That's the simplest idea for you to have. Right. Second one that I would like to discuss. Now, how do you change this? The line colors, the markers, and then things like that, right? So only thing you should know is use of plot command. So if you take help plt.plot should give you the information that you look for, because that is the one we need to update. So if you look at plot command, it tells some information like this. Let's try to read the help file. So it says plot arguments, scale y, data, and then we have variable, arguments. So usually we will have plot x and y, and x is optional, it says. So that means one array would be enough. Okay, focus on FMT. This FMT is the one we are going to look at next. So the FMT means how you represent the colors, how you represent the markers, or how you represent the line types. That's what we call FMT. So if you go down, so this called formatting string, that is a FMT. It says you have a marker, line, and colors. So which means you can change the marker, like whether you are going to have a circles or triangles. Line, whether you are going to have a solid line or a dash line, which color you are going to use. So that can be done with FMT, right? So markers comes like this. You can see these are the symbols we can use. These are the line types. Right? These are the colors. Okay, so everything is in the help. Let's change some and try to understand the code. So I'm going to copy paste the same code. I'm going to keep the code as it is, but let me change a bit. Right? Now this plot command, we can, as a string, we can give the change. Now for example, let's say I want to change the color blue to red. I just put R, and if you rerun, you see my color is red, right? If you put G, the color will be green. Yes? If you need more information, what you should do, just type help plt.plot, and if you go down, yes, it will list all possible combination of the values. So what I have gave you is only the color. So everything is here, right? So the standard, actually you can use any color you want, but these are the basic colors. So R I use for red, right? Similarly, let's change the line types, right? So if you use, okay, dot, 2 dots, right? Sorry, we have dash, 2 dashes. That's the 2 dashes, right? And dash and dot and 2 dots, colon. So let me try. So what I said was early we have green. Let me put the say dash. No change. Let me put 2 dashes. You can see dash lines. Then we can have dash and dots. Dash and dots. And then I can have 2 dots. These are the different line types. The next one is a marker. If you look at markers here, you can see there are different markers are available. So for example, if I type simple O, it's a circle marker. Simple V, triangle down marker. So let's try those two. So let me put O. Yes. Let me put V. Yes, you got how to change the color, line type, right, and the marker. Done? Finished? Yes. Let me give you a little bit more complex one. Let me explain this code first, right? Same thing, I'm going to have a more detailed description of this. So let me start a little bit more complex one. In this one, I'm going to draw a mathematical curve, the sine of x. So x values, I'm going to define like this. I will say np.a range. We have to have the starting value. So I will say this is minus pi value. So to get mathematical pi, we can say np.pi. So basically it starts from minus pi, go to plus pi. So np.pi. With the step of 3. So now you know what will happen. We have a starting value, we have n value. In between we define the step. So that's how we define x. Y on the other hand, I will put np.sine of x. We have x values and y we define of sine of x. Now we know what to put. plt.plot x comma y and plt dot show. So if you have not make any mistakes here, ideally this should represent a sine curve. You see, there's a sine curve here. Yes, finished. Got the answer up to this point. Yes. If you want, you can change. For example, we can say green. V two dashes, and we say green. You see how my graph look like right now. Right. Now this is the simplest form of a graph. But when we want to draw more complicated one, we have to slightly modify the code, which I am going to explain once you finish this. If everyone is finishes, let me know. Have you finished all? Right. Can you copy paste the same code? I'm going to slightly update this and I will explain why I'm doing this. So I'm going to copy paste same code, but I'm going to slightly update this. Right. If you are drawing a simple one, you can use this form. But let's say you want to draw a little bit a complex one. Then we are going to, slightly updated version of the code. So the first thing that we should do is, when you have a get like this, right? For a updated version of the code, we will usually separate out our graphic, the figure. So we will put a code like this and the axis using subplots command. So this command I will revisit where when we want to have multiple plots in the same figure, we can make use of this. So basically what we do here, we separate the figure and the axis. Now the plotting command should be now put into the axis label. So instead of PLT here, I now put it as to axis. We'll put axis.plot, ax.plot. Same thing can go like this. The plot command here should goes to the figure. I will put figure.show. Nothing much change, but this is an additional line we put for more advanced plots, which I will explain. But when you get the outcome, more or less, you will get the same code. more or less you will get the same code. Okay, although this is a graph, you can see there are a few issues. We have not labeled axis. We have not provided a title, a legend which is describe the figure in detail. So therefore, I'm going to get another code and try to improve the code. So this is my starting code, right? So let me run. Nothing has changed. So let's provide the title for this. Providing title will be like this. We will put axis, set title, and then you provide the label for the. So I will say y equals sine of x. So if you run this, now you notice that, okay, we have set up the title. Similar to that, so let's put up the x-axis. So we will say axis, set x label, angle, in radians. So now if you run this, you should notice now x-axis we put angle radians, axis set y label, we'll say sine of x. So now you can see we have labeled both the axis. To more improved visibility, we can also set the grid. We can say ax.grid method. And if you run this time, notice that we have this what we call the grid for easy access the attribute values. And then we can have like the legend. So we can have ax dot so now you see we have a complete example, right? A simple line graph. Simple line graph. Done? Finished? Done? Finished? Right. Shall we move to the another one? So in this one, I am going to explain how you can have multiple data sets. So let's say we have multiple data sets. So right now we have X and Y, only one data set. So let me explain the code. Plotting multiple data sets. Right, let me define nuvex np dot range. We have this time I'm going to extend to -2 pi np dot pi comma 2 pi with the step of 0.01, right? Small variation. Now the next one is we can define several y's. So let me say it's y1. I'm going to get the sign of x. y2 np dot, okay, earlier it should be np. So np dot sign of x minus np dot pi divided by 2. So let me put y3 so we have np dot pi. So these are the y values. So the same command we will have separately figure and axis labels, subplots, axis dot plot x y1 x y2 x comma 3 y3. So we have x value pairs for each of these and simply we are plotting. Right. So you can see 3 lines using 3 colors. So let's put up a legend. We have sine of x, sine of x minus pi by 2, so we have now defined 3, because the first one is sine of x, second one is sine of x minus pi by 2, finally x minus pi. So let's run and observe. So we have the labels right now. Right? So in this is an example where when you have large number of data, right, we can go for direct plotting like this. So, can I have your attention? One way is you can put xy, xy, xy like this, or you can have 3 separate commands. xy1, xy2, xy3. Both ways works. Right. Shall we draw multiple figures? Right. So the right now you can see everything is drawn in a same graph, right? So let's start with the new one. I'm going to get the same code because it's easier for me. But slightly I am going to update this. Make a note of this. So x will be the same, y will be the same, but here I am going to change a bit. See whether you can understand. Now I am going to get 3 axis labels: ax1, ax2, AX3. Reason, I'm going to have 3 different plots, and we will say 1, 3. The idea is 1 row and 3 columns. Now what I'm going to do is, instead of putting this, let me remove both of them. So when you run this, you will get something like this. You can notice now we get 3 different locations. So now let's add the plot. I will get first one, plot x comma y1. So if I run this, you can see you will get one graph here. Similar to that, we can say ax2 dot plot x comma y2, ax3 plot x comma y3. So if you run this, right, you can see now we have 3 graphs, but there are some overlaps. To remove the overlappings, we can say fig dot tight layout, and finally we can say fig dot show. So let me rerun, and you can observe now you can clearly see the 3 graphs. Right, finish up to this point? Yes? Right. Now that we have discussed various ways to create, let me create a bar graph. So let me define x. So far we have discussed the plot command. So the final parts, I would like to discuss some other graphs. So in the bar graph, simply instead of using plot command, we can use bar, right? Same thing. We'll create figure and axis. Subplots command, and usually we use plot here, right? We use plot here. So instead of plot command, put bar here. So usually if you put like this, it will be a line graph, just put bar. We'll create a bar graph like this. So to get separate values, so maybe you can use distinct values, not like this. So for example, let me say instead of x here, let me define some distinct value. Let me put, let's say, x equals np.array. Let's have 0, 1, 2, 3, 4, and let's say y equals np.array. We'll have 10, 20, 30, 50, 50, and let's say 60. You'll get bar graph like this. So only change from what we have discussed earlier, the change is instead of plot command we use bar. By changing, you can change the type of the graph. Right, last graph. So this is bar graph that we have discussed. Only change from the previous codes that we have discussed is change of plot to bar. Have you all finished up to this point? Yes? Need some help? Okay. So the last one under this. So let's have some pie chart. So usually pie chart we can have some values. Since we are going to represents a value in percentages, usually pie chart, the numbers usually we put should be added to 100, but of course if it is not added to 100, usually it can scale these values, right? So the other codes are the same. We have subplots, and then instead of plot, this time we are going to say pi. So with that one we can get very simple pie chart. You can notice something similar to this. So this is proportionate to the values we put. In this particular case, I had make sure that values are added to 100. Now you see here it's not very clear, no labels, nothing at all. If you want to have labels, you have to define another vector or a list. So let me put the labels as L. and then I will put labels, let's say A, B, C and D. So now what happens? We want to say that we have to define the labels. So under X I will put labels and then I'll put L to say that okay, that what we have here is the labels. So we have defined separately. So now you can see our pie chart has updated with the labels. If you want to have percentages as well, usually what we expect, you can change it in the same place. This is called auto percentages, PCT. You have to be very careful about the symbols we use, percentage value we have used. And then we have to put how many decimal places we want. 1.1F, this is the formatting string that we have discussed early. And then another percentage would display the value together inside the pie chart. So once you put it this form, and if you run now, you should see the percentages values inside. This formatting is actually coming from the formatted strings that we have discussed in the input and output under the formatted outputs. So any of these commands, if you want to know the details, you can always type what? Yes. For example, pie chart, you can go to help. We can say pie should give you the details. So for example here, if you read the documentation, it will tell you exactly how you should use the command. For example here, the detailed description version. So the pie X, explode, no, none, labels, none, colors, none, auto percentages here, none, the distance value. So there are many others that you can actually change, right? So all the information is here, like we discussed earlier. You can actually check how to put them in. So for example, this is where the place we use the formatting string, how the percentage value will be represented with the pie chart. Okay, done, finished. So let's summarize what we have discussed in today's interactive session of meeting you all. So we have completed 4 tasks today. The first one, we look at the data structures, and particularly we focus on discussing the dictionaries, right? How to create dictionaries and the users. That was our first task. and manipulating dictionaries, the basic ideas how we storing data. Second thing we discuss is substrings, and I told you this idea we can use when we manipulate the data sets as well, which means when you want to take part of the string. So we discuss how to make use of substrings. So that part we discussed. Then we also get, as a second task for today, we look at the basic idea of OOP, because I told you like most of the data types, the things implemented in Python as classes, and when we incorporate all the methods, we should know what is inside. So therefore we had a very simple example of creating a class and how to use them. As the third task, we started looking at the libraries. So we have completed 2 libraries today. NumPy is for numerical computing. We look at how to create vectors and matrices and how to manipulate them. That part we did. And the final part for today, we looked at the visualization using Matplotlib, which is again the basis for visualization. Right. So those are the things we have completed, and my next class I will explain it to you the machine learning. So let me briefly show you like what we are going to do. So the work that we are going to plan next week, actually we are going to try out all the things that we have learned so far. So before that, please refer the note and come if you want to understand what is going on. So our first example we are going to discuss next week is on machine learning in Python, and basically we are going to look at classification problem where we want to predict the type of a flower, right? So the data set is about like 150 data points with 4 features, the 4 measurements of the flowers. So we will discuss the ideas that we have discussed today, how to make use of the data. So you can see the NumPy as well as the plotting functions that we have discussed today. Will be discuss it again, and also the different data structures that we have discussed also come into play. So make sure that you go through and come. So under this one we will discuss for example how to get the first 10 rows, which we have discussed today. Remember I told you like you need this. So once you have the data set, we are going to see what is inside. So the slicing ideas that we have discussed today is very important. You will see we are going to talk about again next week. And then visualization, again plotting command we did. This plotting we have not done any filtering. We plot it as it is and we don't clearly see anything. But with the fancy indexing, remember the idea we discussed, filtering data based on values. So I have filtered the data based on the class labels. The idea I have used here is a fancy indexing which we have discussed. So once you filter the data, we can color the graph according to the different colors, and now you can clearly see some separations. And then we will discuss particularly the ideas for machine learning, which I'm not going to discuss today, but I will discuss next week. So how we are going to build a model, machine learning model, and how to train them, and also how to display them. For example, the example that we are going to discuss is called a decision tree. And then based on a decision tree graphically visualized like this, we can understand how we can classify data automatically, right? So that's the plan for my next week. But remember, most of the command we have done so far, you have to go through and come back, right? So make sure that you we'll refer the notes and come back next week, because otherwise you might not understand anything at all without the basics. So having said that, that's all for what I have. So we have Veranda here today, so maybe Veranda, you can take over the class now.
Yeah, I just want to review few things. Yeah. So have you stopped for the thing or no?
No, I didn't. So maybe we can have tea. I don't know whether tea is ready. Is it?
So if you stop for a while, I will have a quick review. Small break and small time.
Yeah, I think they need a break. They need. This is in your wallet environment, your Google account. In the drive, there's a folder for remote. In that, it's same. So, all the codes, everything is there. But if you want to download your local music, you can click on the file and download, and that file you can keep it in your machine in case if you lose anything. The notebook version would be better, the first one is. And that version you can later on convert into a